So I want this to be a conversation, ask questions, offer suggestions, feel free to speak up or just raise your hand or whatever. I don't use slides, I just try to look into what you know and what you're interested in, etc. So, but let me start a little bit with where this is coming from. If you look at any system, whether this is a human-made system or a natural system or an organic system like, well, nature or the economy or whatever, you can look at it fundamentally in two ways. One way is to look at it as a collection of things, right? Things as the first-class concept. So everything that is so things, and then on top of that, relationships, and forming structures with those things, right? So ontology, everything is objects or resources or things or connections between those. The other way to look at it is to see it as events, and events connected in processes, right? So everything is something happening at a point in time, and everything is just a consequence of things happening over time, right? So we can see the world as this happened, this happened, this happened, or we can see the world as this thing, this thing, this thing. And it's not that one of these is right or wrong. There's just different ways of looking at it, right? There's, well, you've probably heard this line, right? All models are wrong, but some are useful. That's this kind of thing, right? It's a way of looking at the world. It's a way of looking at any kind of system. We can take this even further, and what Jerry Weinberg calls the 3 B's. So that's being, like this, behaving, and becoming. So this is basically the 3 types of processes in these systems, right? Being is all the processes that preserve structure, right? All the events that basically are there to keep something the way it is. Behaving is everything that is repeatable, all sort of processes that happen over and over. Of course, there are always different, they can also be variations, but it's everything that sort of leaves the system as it is, right? It does things, it does something productive or something that we're interested in, but leaves the system as it is. And becoming is then, of course, the change of the system, right? It's how the system evolves. It's all the processes that turn a system from one thing into another, right? So it's the learning of the system. You could think of it that way, right? This is, these are concepts from systems thinking. So it's, well, maybe a bit philosophical, but I think it's a good way to start thinking about what I'm trying to talk about here. So what I am trying to talk about, and this is basically spoiling the ending, is I think that in software, right, when we model software, when we think about how to construct software, we look at the domain and we interpret it, I think, too much like this. Most of the systems we build, and I'm specifically talking, because that's my experience, I'm talking about systems for businesses, right? Line of business applications, anything that manages, resources and people and all of these things. So I'm talking about those kind of systems here, software systems. When we try to design them, when we try to model them, I think that we are too much focused on finding structure, right? Finding the data, finding the entities, finding the resources, right? Finding the relations between those. And we over-focus on that. I'm not saying it's wrong. I'm not saying it's harmful. I think it's constraining. I think that because these systems that we built, the purpose is in fact behavior, right? We don't build them, most of the systems, right? Most of these systems, we don't build them just to store stuff or to represent things. We store them to actually do things with them, right? And all of these are processes over time. So I think we're sort of under-focused on process and events and behavior as opposed to structure. Right? That's basically the pitch I'm trying to bring here, is to convince you to start looking at systems more from events and processes. Right? Maybe we should first see what your experience is. So who has been doing domain-driven design on the job maybe, or a lot of people? Excellent. For who it's completely new? All right, good. Event sourcing, who knows what it is? Who has? Excellent. All right. So that gives you an advantage for where we are. For the people who don't know what event sourcing is or who have very little experience with it, maybe somebody wants to offer a definition of what it is. Everybody who raised your hand, you should be able to maybe formulate a definition. Don't be scared. It's not, there are no wrong answers because there's no official definition as far as I know. So anybody wants to try?
Let's try recreating the state basing solely on the stream of events in time.
Yeah. So I think that's definitely a good start of a definition. I think there's a little bit more to it that we should add to that. But let me start with that. So if you've never heard of it, basically, if we store all the events that happen to the system, we can recreate the state of that system. That's somewhat different from just storing the state of the system. Right? If I store the state, I know, all the things in there, the entities, the attributes, etc. If I store the events, so something has happened, I store the fact that it happened along with the attributes of what changed, and I store all these in basically a log, a history, an event store. I can reproduce the state of the system. Is that making sense for people who have not heard of it? Okay. Of course, it's not that new. Accountants have been doing it for hundreds of years, right? Proper accounting, you store every transaction. Banks do it. You store every transaction. And then if you want to know your balance of your account, you just calculate you project it from all the transactions, right? You add up all the numbers and you get your states. The difference, or well, not the difference, but event sourcing takes this one step further by applying this to the entire state, not just to typical transactional stuff or money or these kind of things or invoices, but to everything that happened in the system. I would actually go one step further in your definition, because this is, what you describe, I call this projections, or events-based projections or whatever, or events, I don't know, stream processing, or there's a whole bunch of words for that. I go one step further and I would say that it's event sourcing if your event history is also the single source of truth for adding new events to the system. Right? So basically, it's not just, here's a stream of events, I process it, but when I want to add new events to that stream, I use that history, that stream of events, as my single source of truth. Right? So that's sort of the, well, sort of the technical context of where this thing comes from, right? I've been very interested in event storming and event sourcing and these kind of ways of designing software for a long time, and that's how I started seeing that maybe we're still, even people who are doing event sourcing and event storming, I think, are still over focused on things and entities and structures. All right, is this making sense somewhat? So, well, I'm a DDD guy. What we do in DDD, of course, is try to model our domain, try to understand our domain, and explore it, and make sure that we know sort of the concepts, and we discover the language, and then try to use that to design a model to come up with a way to represent that problem space in our code, and keep our code basically looking like the problem space. A lot of code out there looks like, well, very technical, right? It's all kinds of, database calls and queries and all kinds of technical language, basically, and it can be very hard to see what the original domain was, which slows us down when we're trying to do, evolve a system. So in DDD, we're trying to model the domain. I never say model the real world because, well, you cannot model the entire real world, of course. We always find some subset of that domain that is relevant to put in software. But when we do that, I think even in the DDD community, we're still sort of too much focused on basically a data-centric view of the world, right? where you start from, this is the data I want to keep, and I build an application around it. But that's not the purpose of these applications. Right? The purpose is to do something, and storing the data is almost like a necessity. It's like you need it, of course, to do stuff. But the point is, very often, the point is not to store the data. The point is to do something with that data. And that's what I want to look at here. So maybe I should try to do this with, well, let's start with something very simple. You know, we have a customer, right? The customer is an entity. It's something with an identity in that domain. I often even make a distinction between a domain entity, something that exists as a concept in the domain, and an entity object, something that we represent in our code. And of course, very often, these will match in a traditional object-oriented model. And that's sort of how we've been doing modeling, right? So find the nouns. Oh, there's a customer. That's my noun. That's the concept I'm going to put in my code as an object, and then start adding stuff to it. But another way to look at that is to say, well, something has happened, right? Could be somebody walks into my store, maybe it's a physical store, buys something, right? The next day, somebody walks into my store and buys something. These are both events, right? These are observable, right? These have happened. Somebody could, you could be standing in that store and see that happen. So that makes them a little bit more tangible in a sense than the customer concept. Because so far we've had these two observations, right? I can see this as, well, let's just say these are two events, right? The next thing is if we start looking at these two events and we say there's some relation between these two events, right? The relation is that it's the same physical person who walked in on the first day and bought something, and who walked in on the second day who bought something. It's the same physical person. And now I can make a business choice, which is I am interested in tracking those two purchases, in seeing that relation, because I want to do something with that relationship. Right? So it's a business choice to connect these two and say, well, they are somehow have some shared identifier, which, what should we call this thing? Well, this symbol means the start of a process. This is the end. So now my process, I don't know if you can see this. Yeah. The process starts with somebody who walks in and buys something, and I think that I'm interested in the fact that this is the same physical person. But that's a business choice, because I might also not be interested in that. There's in fact many stores, physical stores, where you walk in, you buy something, the next day you walk in, you buy something, and there's nobody tracks that. Nobody is keeping score. So that's a choice, right? So the fact that these two observable events, these two facts, are connected is already a choice. Right? I could also choose not to track that, but to track, for example, what they bought, and then maybe, so here's, other disconnected observable events where somebody walks in and buys something, but here they bought product A, and so I connect these things. And now I say this connection between these events is this relationship between these events is sales for a product. Right? Maybe that's my thing that I'm interested in. So is this making sense that this is a business choice fundamentally? Of course, very often we don't even think about it like that. We just say, oh, we have to track the customer or whatever. Of course, in software, very often we will always track the user. We will always connect. We're even trying to connect events from the same person when they haven't even signed up for our system or something. We don't know anything about them, but we're using things like IP addresses and whatever and other behavior to still find a way of tracking them. So for users, it's usually, we do it anyway. But what I'm trying to get at is that if we start by saying, oh, this is my boundary, this is my entity where I call this customer and I call this something else, inevitably you will find that the business needs something that is a relation between those things, and then it starts to get very tricky, not in a simple system, but in a large system, to what is where and which thing knows what, which has what information. Right? Is this making sense? Any questions so far? Or anything that's unclear about this? All right, I'm just going to trust then that you believe me. So what I'm getting at is when we start modeling, instead of starting with customer and trying to, or product or something else, the interesting thing here that we cared about was not customer or product even, it was sales per product, which is sales per product is not product, right? It's a different thing. It's a different concept that we're interested in this example, right? So when we start modeling, we shouldn't start modeling from finding all the data that we want to store. We should start modeling from what kind of processes do we want to happen, what kind of information are we really interested in, and start drawing around it, start designing around those concepts. All right. Maybe I can do another example with well, let's take employees, and maybe so again we could start with a very sort of entity-centric view of the world, where everything is a thing, a concept, an entity with attributes, etc. And we say this is an employee with a name and whatever. But then later some change comes in the system, and maybe now we want to start seeing things differently. We want to start seeing or modeling it as different types of employee. Maybe there's managers and I don't know, factory workers, and we want to do different things to them and use, have different processes and different, I don't know, salaries and whatever. So if we start from this, now we have a problem that our system looks one way, but our desired model looks different, right? And the problem with this is that it doesn't really, we can change it, of course. We can change our database schema, we can change our domain model, but usually these changes are tricky, right? Usually these migrations are painful. So, but if we see this as a series of events, those events are observable facts that happened, right? Somebody was hired, and somebody else was hired, and somebody was promoted, right? And somebody else was, I don't know, hired again, or maybe somebody was, somebody quit, etc. If we understand that process, if we have kept track of the observable facts here, then changing our model now, where we say some of them are regular employees and some of them are managers, something like that, now becomes a projection of all these events, right? Is that making sense? So this is the concept I was explaining earlier, projection as look at a series of events, interpret them some way, and build our structure from that. So now the migration actually becomes very cheap because it's only a projection. We could have a new projection that looks at these things and interprets them differently. So instead of saying this is an employee that gets added or removed, we can now say, well, this is moved from employee to manager, or from laborer to manager, or vice versa. Right? So the resulting structures are now only a consequence of the events as opposed to the main thing. Is this making sense? If I'm going too fast, please say something, because I just see people nodding.
I have a question.
Sure.
I'm not a master DB, but I've worked in both, and sometimes there's a mention of an aggregate road.
Yeah. Let's get to aggregates a bit later, if that's all right. So if I forget, just remind me again in probably about, I don't know, 10 or 20 minutes.
You said that the structure emerges from a series of events.
Yes.
But first of all, we need to know what kind of attributes we need to gather with each event to be able to
Yes.
build the structure out of them.
So yeah, but the thing so the attributes of the events can be minimal, which is They only contain the attributes of what changed at that point in time. Right? So an event is always a very specific granular point in time where something has changed, something of relevance. How granular, that's a whole other talk, but as granular as the business needs it, you know. And so so this one, for example, somebody got promoted. What do we need to know? Well, who it is, so some identifier, what they are promoted to, and maybe some timestamp, right? A timestamp. If you have that, we don't really, there's nothing else that actually changes, right? We just need, and it's always these kinds of things. Who does it happen? Who does it? Who does it happen to? What's the thing that changed? What is the timestamps, the identifiers, those sort of things. They're actually fairly easy to find these. You're going to, with a little bit of experience, I don't think people generally get this wrong, because it's really just such a fundamental building block of what happens in systems, right? At that point, well, like a bank transaction is a very obvious one, of course, where at this point in time, so before this specific point in time, this money was not in your bank account. After this point in time, this money was in your bank account. So what do we know? What can we observe about this? Is that there's some amount, the change. There's some point where it happens, some point in time, and it's your bank account and not mine. So that's all we know at this point. So we usually don't get that wrong very often. Sometimes you miss something, but there's some heuristics that can help you to find the right attributes. We don't choose those attributes in order to construct a bank account, because they will be there anyway, right? We won't be able to construct that bank account without, or construct that balance of that bank account without those attributes, if that makes sense. So it's not a matter of already knowing up front what kind of entities we will need. It's observing the events that are relevant, and then we can project our entities from that. So what I'm getting at, so the example with the first one with the customer, or this one here where we change our model from everything is employees, we evolved it to we have I don't know, laborers and managers, right? This is still sort of a simple transformation in an object-oriented system, but still things might depend on it, and that's what makes migrations costly. But this has not changed, right? The things we're interested in, or interpretation has changed, but these have not changed. So what I'm getting at here is that entities are not facts anymore in this temporal modeling mindset, right? Entities are choices. Events are fact, right? So events are discovered, right? They're not modeled. Of course, there's a choice element in there that we discover some event and the business says, well, yeah, we're not really interested in that, right? Are we interested in, I don't know, how often does the customer look at the product? Oh, maybe not, right? So we're not tracking those events, but they are observable events. So we discover these events that they happen in our system. We choose to use them, but entities are always a choice in this mindset, right? It's not, we discovered that there's also, a product entity or a customer entity. It's a choice that we want to use those and model those. So it's not that, when I was talking about this, that these are completely different things. There's always going to be some possible mapping from all the observable events into the state, into the structure. It's not that they are, that one is wrong and one is right. They represent the same things, but we look at them from a different angle. Right? But the whole projection thing, that's what makes it. That's one of the very interesting things about it. Is of course that this mapping exists from the events to the structure, but there's no guaranteed mapping from the structure to the events. Right? If I have kept track of all the events, everything that happened to my system, everything that changed, and the point in time that it changed, and who it happened to, etc. I can always reconstruct, reproject any state, but I cannot, if I only have the latest state, it's basically lossy, right? If I only have the latest state of something, I cannot reconstruct how we got there, right? This is incredibly powerful. If you've never worked with event source systems, this is sort of the magic thing that suddenly enables a whole kind of a whole range of possibilities. Was that sort of answering your question? Because I think your question was about, yeah, knowing what is in the events, right? Was that the?
Yeah, I believe that we need to like cover only some amount of data that got changed.
Yes. Yeah. Well, it's a bigger story because there's all kinds of reasons to put things in events and not put them in events, etc. But at that point, it's more about, you know, how are the events going to be used by clients, etc. But fundamentally, you can, if you only keep, so a minimal event is basically only the things that have changed at that point in time. And there's something, I call it the guarantee of a system, of an event, of an event stream, if it's guaranteed to be the completeness guarantee. So if these events together allow me to project the state, then this stream is guaranteed to be complete, right? So everything is minimal, every individual event is minimal, but together I can use them to recreate the state of the source system. That means that this stream is guaranteed. It has a completeness guarantee. Right? That's well, we're sort of covering too many things here. So let's take a step back. So let's go back to processes. So now basically I'm proposing a worldview where we're talking to the business and we're not. So what happens in many conversations, this is what bothers me. You're talking to the business, and they're saying, oh, and then a ship comes in, and somebody needs to. We start unloading the containers, and the receiving operator starts looking at the contents of a container to compare it to a manifesto or a receipt, and they're saying all these things. They're describing a story, right? This is how people explain things. It's story. It's things happening over time. And our programmer brain goes, okay, so I have a table with receipts, and then I have a one-to-many relationship to this thing, etc. We're already sort of modeling a solution space. Right? I'm not saying everybody should always do event sourcing. I'm saying when you listen to something like that, to a story like that from somebody in the domain, model it as a story first. Model it as a process first. Right? This is how we have communicated for thousands of years. It's telling stories of sequences of facts. Well, they may not be facts if they're stories, but sequences of events that happened, and from there we look at we can look at structure if we even need it. Right? So what I'm saying is, when you have your first conversations with a domain expert, use something like event storming or something that represents those processes, right? That don't try to focus on naming the things, but it starts with focusing on naming the events in there, and then start looking for how these events combine. What kind of events happen in sort of similar sequences? What kind of patterns do we see there? Always when the ship comes in, this needs to happen, right? And then that happens, and if that fails, that happens, and start looking for that first. And then even if after that you decide, we're going to design this as a traditional object-oriented system or something like that, we're going to use, I don't know, a traditional relational database or a document database or whatever, keep going back to these processes, right? Keep going back to these processes that describe the purpose of the system, right? The stories happening in the system. I will even argue that if you read Eric Evans' book, even though it's very much in the sort of 2000 era, Java was all there was at the time, and that's how everybody did software. And he describes sort of, with entities and these kind of concepts. he describes something that on the surface looks very much like structural models. And they are structural models in the sense that all the examples in the book are entities and things that are connected with relationships. But the way he gets there is to keep looking at what happens over time. Right? He keeps looking at, and he keeps changing it. And he keeps, if you follow sort of the examples in the book, he keeps sort of remodeling and rethinking it and identifying new concepts in there. And every time when he finds one of these concepts, it's really because he's been looking at how the process really works. I think the example, I'm not sure if I recall the example correctly, but I think the sense was something like this, where it's shipping containers, right? And it starts in some city, and he starts by modeling the legs of the voyage, right? This is from I don't know, Shanghai to what would that be? I don't know, New York or something, to somewhere else. And he starts by modeling these legs and their entities, and he adds attributes to it, etc. But then he starts refining it and starts having more conversation about how things actually work. And it turns out that during these legs, which is basically, this is the part where the ship is at sea, right? Nothing actually happens there, right? There's nothing that happens while the container is at sea. It's just, I mean, it's moving, of course, but there's no interesting business events for a shipping business. The interesting events happen here. So he starts modeling the stops. He said, well, the stops are actually more important, right? And of course, a stop is an entity, but the way he looks at it is the process, is the story. And then he starts refining it again, and he looks at, well, what happens at the stops? Well, at the stops, there's actually some kind of handover, right? It turns out that because it arrives, the container arrives with at this dock with I don't know, this handler, and then they have to hand it over and put it on another ship with another handler, and then it starts the next leg of the journey. So the thing that we're interested in is the handover, right? Again, it's the process. It's those events. It's literally the transaction of that container from one party to another. And then, of course, he ends up with a model where it's still entities. The handover is an entity, and every intermediate or every stop has actually two parties involved, and he's modeling all of that as entities. But the way he got there is by thinking about the process happening over time. Right? Imagine you had been stuck with this model of legs first for a really long time, and then after everything depends on the legs, and then you realize only, well, actually the handovers are more important. It gets very tricky, right? This is where we get stuck, where our software, the model doesn't fit the kind of things we want to do anymore, and it becomes very hard to, and it's not just even that, it's when we are stuck in a mental model, in a mindset of something, it's very hard to get out of that. This is why a lot of software sort of feels awkward to evolve it, and it's very costly to evolve, because it's hard to even see that another model is possible. Right? So this is one of the reasons why I'm advocating temporal modeling, which is I think it helps you break out of your existing mental models. Because if my model is legs of a journey and I can't break out of that, if I do temporal modeling and I look at every event that happens, oh, this is when it arrives, this is when it's handed over, this is where it's signed off, this is where it's loaded on the next ship. Right? All of these are events, points in time where something has changed. And I draw all these events and I start looking at them, I will probably see that, well, this whole leg part, nothing happens. It's not interesting. Why do we even have this entity? Somebody like Eric Evans is a master modeler who sees this stuff. He looks at it and he has this sort of brain, basically. Most of us don't, so temporal modeling to me is a way to figure this stuff out easier, right? To make it accessible to us mere mortals to do better modeling. So I'm not advocating a specific methodology. I'm not saying do event sourcing or whatever, but I'm saying look at methods that help you find time. Ask this question: what changes? How often does it change? Who does it, and how does it happen? And what are the consequences? That's a very good question always. You know, if this thing happened, what are the consequences? If this other thing happens, if this goes wrong, what are the consequences? Who is affected by this? Who needs to know about this? I keep looking for these things. That's a whole different set of questions than what are the nouns in this domain? What things do we have, and how are they connected? Right? I'm not saying that's the wrong question. I'm just saying that this other question, in my experience, is much more helpful, right? And gives you because what I was saying earlier, right? That these events are observable facts. They can be discovered, and it's not so hard to discover them. And then you start modeling from there. Is that making sense? So I'll add one other thing to that. Let me just make some space. So the point of all the software that we're building, if it's not some software is about storing stuff, right? If you're building, I don't know, software for a library, and even then it's the process of checking out books. But all the software that we're building for businesses, it's trying to do some things, and it's if we start thinking about it, a lot of it actually has constraints. Well, we call it business logic or business rules. I think that's another, maybe an interesting presentation would be about what kinds of rules there are. Some of them are physical rules, right? I cannot sell you this item if I don't have it. Well, I can sell it to you, but I cannot give it to you if I don't have it in stock, right? So the I cannot send it to you is a physical constraint of any scarce resource. The I can sell it to you or I cannot sell it to you is a choice, is a business choice again, right? Some companies will sell you stuff they don't have in stock and then try to get it. Some companies will not sell it if they don't have it in stock. That's a business choice. But all of these things I just call them constraints in general. And they are things that, they are basically the essence of why we make this software. This is because we want to constrain things. Very often they're enabling constraints. Right? We want to constrain how people use our system. If you're, I don't know, on Twitter, you cannot tweet something when you're blocked. That's the point of that is to enable something, which is the whole concept of not seeing somebody's tweets if you don't want to see them anymore. Right? That's why we block something. So that's a constraint. It's a business choice, of course, of how that works. You know, if this person has blocked you, you cannot see their tweets. They will not see your tweets. This sort of thing, right? All of those are business choices. But the purpose of this feature is enabling something through the use of constraints. Well, same with the example of selling the item that is in stock. I think Amazon will usually sell you the thing even if they don't have in stock, and they will try to find some way to get it. And occasionally that goes wrong, and they will, I don't know, give you your money back, or I don't know how it works. There's a company where I live that only sells things. They're like the local Amazon. They only sell you something when they do have it in stock, as a hard rule in that organization, because they do next day delivery guaranteed. They do same day delivery even, which is very hard for all their products, which is very hard if you don't have it in stock, of course. Then you cannot do that guarantee. So that constraint again is enabling some business value or something of. So that's why we built this system. So now if we start looking at a system as events happening over time. Every constraint, so there's two ways of looking at it again, right? We can look at it as state, and I can say somebody is trying to buy this system, buy this item, a customer, and we can say the rule is this item must be in stock, right? So I can check some states when I'm trying to. So this is the new event I'm trying to write. The new event is item was bought or item was sold or something. And in order to be able to make that decision, so there's a decision being made here, I can sell that to you or I cannot sell that to you. We can look at it as it's based on some state. There is some state here that we can query, which is the amount of stock for that item. Right? If it's and the rule is if it's 0, we don't sell it. If it's 1, then or more, we can sell it. That's the state-centric view of the world. But we can also say this decision point here, this basically this constraint that says we can only sell it if we have it in stock. We can also say, well, this depends on everything that has happened before. That's the temporal view. This is the structural view. The temporal view is it depends on the history of that item. Right? For example, that item was introduced in the stock. It was we added so as a new a new item that we sell. We added three items or a stock of 3, and so something was shipped to us or something. We put it in our warehouse, and then item was sold, item was sold, item was sold. So this decision here, this one, depends on everything that has happened before, and makes a decision based on the history. Right? It's almost the same thing. It's just a different way of looking at it. Right? We're not just saying it's based on some state. We're saying it's based on a history of changes. Is that making sense? You could say, well, this is much simpler. Yeah, I mean, the implementation of this is simpler because I can just query that state. Whereas here, I basically need to query the entire history and calculate how many items I have. So basically, it's +3, -1, -1, -1. Of course, that's a very simple calculation, but it's some work I have to do. I could cache that, of course, so it's not necessarily going to be expensive. But the point is, of course, that this, if we start looking at what is this thing here, if we want to model this as a state, as a structure, where did it come from? Well, because every time something happened, it updated this state. Right? So the arrows that I drew here from the constraint, right? We cannot. The constraint, as a reminder, the constraint is we cannot sell it if we don't have it in stock. We could make that decision based on history, or we make it based on state. But the only way we can get that state is basically with the exact same arrows. Right? It's the same arrows going to the same events, the same logical dependencies. Right? We can only calculate this if this has happened and if we know about it somehow. So again, structure and temporal modeling, it's the same concepts. We look at it from a different angle. Right? But here, if we only store a number here, then there's a whole bunch of questions that we cannot ask. Right? For example, maybe there's a new rule that comes. I'm just making stuff up here, but we cannot sell this item too fast, right? I don't know why. Maybe there's some regulation or something. We can only sell 1 a day, something like that. If all we had was the state, the latest version of that, there would be no way to decide that. Of course, we could build a new feature that starts tracking that, which starts adding here, I don't know, sales frequency or something. But then we don't have historical data to use it on. Right? So again, I'm trying to illustrate that a temporal understanding of something enables new features much easier and changes and new structures more easy than if you only have existing structure and not how you got there. Making sense? Any questions about this? So maybe, have you done any event storming? Is that who has done it? Who knows what it, well, who doesn't know what it is, maybe, yeah. All right, excellent. So it's just one method, of course. So I'm proposing a mindset. Event storming is a method, right? And event sourcing is a method of doing things. but this is sort of what I do in not in this sort of the first. Typically, event storming, you start using it as a domain discovery tool, right? What's happening in this domain, etc. This is more when I do sort of very precise design level event storming, when we're really trying to figure out how a specific bit of model is going to work. And then I do this basically with post-its. I find the events first, all the observable things. Something is sold, something is bought or added or whatever. And then I start looking for those constraints, and I start having these conversations with the business. Okay, what are the rules here? What are maybe even what are the underlying concepts for the rules? Right? What physical constraints do we have? We can even start having conversations about what if what we recorded doesn't match reality. For example, the system thinks that we have one item in stock, but somebody in the warehouse looks at it and says, well, that item is not in stock. How do we do that? Right? I started having these conversations, and I tried to model this in very precisely. And then I write down all these constraints as well as stickies. And then I start drawing these arrows to figure out how things are connected. Every constraint, every decision point has at least one arrow going back to something that, well, no, that's not correct. Some of them are just inherent, right? They just make a decision. If you pick blue, you win. If you pick green, you lose, or something that doesn't depend on history. But almost all interesting constraints depend on at least one previous event and knowing about it. So you start seeing the dependencies of decision making to the history of events. Right? Why is that interesting? All kinds of things. And this would take a lot more time to explain it properly. But if you have a bunch of events and I have a constraint here, well, let's actually make some more space. So I have these events, and I start seeing that this decision point here depends on this and this and this, and maybe I have another one decision point here that depends on this and this and this. Just from looking at this picture, which of these concepts want to be in the same bounded context and which don't, right? Well, they're tightly connected, these. They have something that connects, even if they don't look. Again, we need a more elaborate example to really drive it home. But even if the names don't suggest that they belong in the same bounded context, the decision making needs it to be in the same bounded context, or needs it to be, not necessarily, but wants it to be close. Could be at a small scale. This decision wants to be in the same object as this information. Could be at a very large scale. This decision wants to be in the same bounded context as this information. But it's basically, we can start drawing boundaries not based on gut feeling or based on the names of things. Oh, everything that belongs to the customer, let's put it in the customer bounded context. Everything that belongs to the orders, let's put it in the order context. And then it turns out that the decision making is, how many orders has this customer placed? Well, in order to figure that out, we need information from both the customer context and the order context. Well, maybe the boundary was wrong. Maybe we based it on the name, but we should have based it on the decision making that happens. All right? So we start with temporal modeling. I start seeing how the system will really behave, and how these are real, almost physical dependencies, right? Some bit of code decides something. How does it decide that? Because it needs to know that these things have happened. Now, in general, as a software design principle, we try to put the decision making close to the information needed for the decision making. I now have a way of visualizing how, over time, in processes that happen in the real domain here, the decision making needs that information, so wants to be close to it, as opposed to gut feeling. Ideally, we spend like a day doing exercises, but we don't have that time. But is this somehow making sense? So if you want to do microservices, right? I've seen very often microservices really, the anti-pattern is entity-centric microservices, right? Where we look at, find the noun, basically keep that old, sort of high school way of doing object-oriented design. But we do it at microservice level, so now we have basically a tangled web of objects, but with the network in between, so it's worse, right? They're now distributed tight coupling. Here, this is real coupling, right? So we can draw our boundaries around it and say that this, maybe here in this picture, the red stuff wants to be in a microservice. The information, even if now I decide I'm going to store this in a traditional way, it's a structural model in that microservice, it's entities and it's records in a database and something like that. The choices that I make of what goes in there are now based on the real need of a real process, right? So good microservice, I'm not going to say good or bad, but if you want something to be autonomous and it depends on something that is, well, let's draw some boundaries to just, right? Let's say this is some boundary and this is some boundary. So is this an autonomous thing here? Well, no, because it depends on something that happened somewhere else. That's not necessarily bad. I'm just saying, there's always going to be some things that need to be connected, of course. No, we can't build systems where something lives in entire isolation and has no input from the outside world. But we can start carefully thinking about where to put something with this when we have these arrows, right? These logical dependencies. And I'm not saying you cannot find them with object-oriented, but I'm saying you can find them a lot easier with this kind of mindset, right? With temporal modeling. How's that working? Maybe a lot of information to process in one. Maybe is anybody who, is there anybody who feels like, okay, this is what I have been doing? I know it's risky. You want to comment on that?
Basically, I've had, at this point of time, the very system I'm working currently on, I have to, let's say, I have a dual approach. And why is that? We have to satisfy the requirements of the architect. So we are storing the data, in fact, as a model in a regular SQL database. But I am storing and rechecking the events all the time. So basically, I am keeping the log. Yeah. I'm always checking that I can recreate the entity from them, from the events.
Right.
But I'm not really basing the model on that, which creates interesting problems because I need to include in like 3 or 4 entities information about their time periods. So I have temporal model inside of the SQL database.
Yes. So what you're describing sounds like what I would call the completeness guarantee, what I was discussing earlier, that you're trying to guarantee, basically test them against each other, right? In a sense, every test is 2 ways of looking at the same thing and comparing the results. That's, one way of describing all tests.
Until I can make my architect understand that we do not need to store the state as a representation of SQL entity, then yes.
Yes, but I mean now you're using it to yes, that's what you're doing, right? To guarantee the correctness of, or at least some measure of correctness, right? Nothing is going to prove that indefinitely, but so. It sounds like sort of a hybrid event sourcing as a, we might just want it, right? Or we might
as a sanity check.
Yeah, as a sanity check. Interesting. So, but what I want to ask now is, when you're talking, well, I assume you're a DDD person and you're talking to the business and not designing this in isolation. What kind of questions do you ask? Do you ask about time and events and process? Is that? what you're doing?
At this point, yes, because we've started to build a system based on the, let's say, grand design. I love this description. But now we can work more closely with business people, so we can ask proper questions at this point. So we can finally ask them the proper questions instead of relying on the middleman.
Yeah. So the way I define temporal modeling is just as the approach of looking at the system as things happening over time. It sounds like that's what you're doing.
Yeah, because our system is really dependent on the time of events, especially that we have to, from time to time, process events that happened in history.
Yeah.
So we need to go back in time.
Yes.
That's where the periods come, and process the stuff again, but for a different subset of, let's say, a different subset of entities in the system. Not to disclose too much.
Yeah. Okay. Yeah, and the concept you're describing there sounds like maybe it's bitemporal modeling, bitemporality, basically, where you may have some events. This happens in finance, but I've even done this in a government project where at some point a decision is made, a human decision is made. We store that fact as an event, and later new information is added to the system. Some of that information is maybe even a correction of old information, right? We're basically adapting the system to reality. And then the next steps are figuring out, given this new information, so we don't change this one, right? We just add a new one saying this one should have been that one. And now we can reinterpret, would that have been the right decision based on, if we had known this thing, if we had already known it here, would we have made the same decision? Or would we have made a different decision? And can we compensate that difference? So that's another event, right? So when you have these sort of very tricky problems where, bitemporality, adapting the past, reinterpreting the present, correcting things, I don't even know how I would do it in a structural model, because you're always updating state, and then if you're wrong, you lose something, right? Or you would end up with a structural model with so much temporal information that basically you've reinvented event sourcing somehow. And it sounds like that's what you're worried about, that your colleague is maybe not seeing that way yet. So yeah, maybe as a remedy, I would suggest try to visualize, events over time and these kind of problems as that's always a start, right? In time, yeah. But this is one of those. The three B's. We have the events that are maintaining the system, so the being. Some of those are maintenance events, right? Restore something the way it should be. That's a being event. These sort of things, I still consider those behaving. It's still behavior. It's just very complex behavior that depends on readjusting. I keep bumping it. Sorry. Readjusting our knowledge of the past based on new information. Right? Sometimes information doesn't reach the system at the point in time where it happens. Maybe we only learn about something else much later that we should have known, but we didn't know. Right? And then becoming is the actual learning of the system, where there's most typical business software, the learning doesn't happen in the system itself. It's us as developers, right? Something, we learn something new about the business, or we discover a bug, for example, and we fix it. That's the becoming part of the system. So the system is not itself changing itself, but it's us as part of the bigger system, the team developing the software changing the system. Of course, in maybe things like machine learning this is software that actually changes itself, in a sense, so then the becoming also is automated. Right? Is this still making sense? Yeah. So somebody was asking about aggregates. Anybody wants to define aggregates? You've had a lot of DDD meetups already, right? And, well, granted they were in Polish, I suppose. So who's using them? Very few people. Okay, some people. All right. You're probably either using them or you have a bug in your system, but you may not visualize them or model them as such. So again, this is like a topic that is actually would deserve a lot more time. But the problem that we're solving is, so aggregates are not about the structure at all. They are they look like objects, like structures in Eric's book and in von Vernen's book, because again, Java was all there was, and everything looked like an object. But the point of them is this decision making. If you need to make a decision here based on, for example, can I sell this item? The rule says if we have it in stock, how do we know that we have it in stock? Either we check some state, or we calculate from a history of events. And it's really the same thing, because this depends on the same events. Right? But somebody else also wants to buy this item at the same time. So now we have a problem of concurrency. This is what aggregates solve. It's being able to make decisions in a distributed environment, or where there's multiple actors, and getting a much better level of guarantee that it won't fail. So aggregates are really an architectural pattern and not an object-oriented pattern, if that makes sense. Right? Is this like news to everybody, or if you read Eric, the problem in Eric Evans' book is that the sort of reasoning of what aggregates are for are very much mixed with the implementation. So it's very hard to sort of see them separate. The way he explains it now is different. He explains basically aggregates are a consistency boundary. Right? Why consistency? Because there's a rule here that we want to be consistent. Right? I want to guarantee that I never sell this item if I don't have it in stock. So the point of the aggregate is to be a consistency boundary. How do we achieve that? Well, transactions, right? Of course, we need to be able to read something and then write something, make sure that somebody else is not writing at the same time. So there's basically a transaction boundary. Or that somebody, I say this slightly incorrectly. We need to guarantee that somebody doesn't write it not knowing or changes. Right? That's what transaction is for. The concurrency boundary is we need to make sure that somebody doesn't make this decision at the same time without knowing about our. Is that making sense? And it's basically the aggregate pattern is a distribution boundary as well, because Martin Fowler's first law of distributed objects is don't distribute objects. Basically the same idea again, that a decision ideally is made with information that is local. Otherwise, it's much harder to give that guarantee. We can do distributed transactions and all of that stuff, but then it's not the aggregate pattern. So in traditional object-oriented DDD, an aggregate is an object that represents that boundary, that consistency boundary, and where the infrastructure guarantees that we will not accidentally write, have two concurrent things writing changes to that object without knowing about each other, or doing it in different places, distributed. or not seeing each other's changes, right? This one already sold the item, but we didn't know it was already sold, so we also sold it. That would be a violation of the consistency boundary. And that's what the aggregate pattern is for. Here, it's just the arrows basically again. We're saying this decision must always be correct. So we need to make sure that when I look at these events, make a decision and write the outcome of the decision, that somebody else is not also writing the outcome of the decision. Right? This is also what I said earlier about event sourcing being new events are added to the stream based on or using the old events as a single source of truth. It's in the same. I feel like I'm rushing all of this, but just trying to get some of these concepts in there. So yeah, that's basically the point of aggregates. So there's many places where you don't need them. There's also many places where if we start asking questions to the business, it turns out that we don't need them, even though that rule is still there, right? This is something I do very often with, my job is basically going to places and helping people do modeling and software design and seeing how the architecture supports it or not and stuff like that. And so one of these questions I keep asking when I always try to get business people in the room is, and I use post-its, right? So this decision point here is we only sell it if we have it in stock. I start moving these post-its. I start saying, well, what if this decision was made later? So, for example, I sell you the item, and then I check if I have it in stock, and then I see that I don't have it in stock, and then I do some compensation, right? Because I have this very temporal view of the world now, I can start thinking in when are constraints enforced, and if they're enforced late, what kind of compensating actions can we do? And how much do we care about the delay there? How long after the fact can we figure out that decision? Can we make that constraint? So again, temporal modeling here as a way of looking at how decision making really happens in domains. Decision making in real businesses, it doesn't happen instant the way we can do it in software. Right? When a programmer says immediate, they mean in a single transaction. So it's happening here. When a business person says immediate, they mean by the end of business, or by the end of by the end of the week or the month, or if it's an accountant, immediate means in the quarter following the quarter that we're doing the reports for, right? So I started asking these questions. I use the post-its to move things over time to see what will happen, right? What if this event happens first, right? What if I use it to discover bugs even, to discover race conditions, these sort of things. In fact, I've seen non-technical people discover race conditions by just moving post-its with events and constraints and asking questions what happens. So what happens if the invoice is, so this post-it, this event, if the invoice is paid before we created the invoice? Oh, that can never happen. Well, everybody, oh, that can never happen. And then someone says, well, actually, this happened a few weeks ago. What? Yeah, of course. So what happened is the customer always pays us, on the 15th, and we were late with our invoices for some reason. So we hadn't invoiced them yet, but they already paid us. And then because that payment came in, it couldn't be matched to an existing invoice because there was no invoice yet. So that when we made the invoice was marked as unpaid, and then it went overdue, and then our system started automatically sending reminders, and then the customer got angry, and then, well, we got on the phone, and we made up, and it's all good now. But they don't want this to happen again. We look like idiots when that happens. So the solution is, of course, to start thinking, well, if this thing happens first, a practical solution in this example would be to somehow store the fact that a payment is unmatched, and when you make an invoice, you can retroactively match it to a payment, this sort of thing. All kinds of solutions. Or you can just instruct your finance people to always double check, right? That might be the cheaper solution than building a whole system for it. But we now have a very visual way of talking to the business about bugs and race conditions in a way that makes it very understandable, because we're talking about processes and things happening over time. We don't start with there's a match entity that threw an exception because I don't know, or it must have an invoice ID and there was this sort of thing. We're not talking in very technical exceptions and failed things, etc. We're really talking about process and possible orders of process, right? So we can actually, I've seen, this was what I was saying earlier. I've seen was the chief product owner of a large company who had discovered a race condition in the software that had never happened before, that had never actually happened, that had never been observed, that the programmers did not know about. A non-technical person discovered a race condition. Why? Because we started modeling from process and time in their world and making it visible, making it very visual, making it very tangible, with event storming and moving post-its around, so that they could actually do this sort of thing. Right? And they started using it for. So temporal modeling is not event sourcing. It's not. It's the mindset of looking at our systems as things happening over time first, especially if it's the kind of systems that are about things happening over time, which happen to be most systems. And then some of the systems are even more complex with the sort of thing you're describing. Then definitely look at event sourcing, etc. But start with understanding the system as process happening over time, decision making happening over time, impacts of decision making causing new processes. So now I've drawn this very linear, but some decision here could cause the process to go in one direction or another direction, and we start modeling this as different consequences. Right? We can even start modeling now the evolution of systems more accurately. So some process happens, and then some other process affects how this process proceeds. I've used this for a life insurance company, where life insurance is a very long-running process, right? You sign a life insurance, and then over the course of hopefully decades, many decades, nothing happens, and then. But what happens is the products change. We change how our agreements work. We want to change our products. We come up with new ways of doing things. We change how we do, I don't know, fraud detection and all of these things. So there's processes for changing how we do things. And then the existing things, instead of saying this is a contract, an existing insurance policy that now needs to be migrated, we can start modeling the impact of one process on another process. Instead of saying it's a thing that needs to change into another thing, we can say it's a process that is impacted by another process, where one event has some. Again, this is the very, very short version of it. But you can start thinking about simultaneous versions of processes now. So we say, well, the original version of this process happened like this, and there's some decision making happening in there, and now we want to change how we do things. So we make a new model. This is maybe our I don't know, our V1 model, and our V2 model works differently with different. But instead of trying to migrate all the old things into the new ones, because what you do if you have a relational database and an object-oriented system with a domain model, and you're trying to change the domain model, and you're migrating things, you're basically pretending that all the old stuff that happened in the new model. Right? You're saying, oh, this happened in this new model, so that everything looks like this single model. But the reality is that it did not happen in that model. Right? And then you get all the sort of problems where, oh, but for the customers from the first version, we don't have this this field or something like that. Oh, let's put a default value in there, or a null value, and then have some check that looks. Well, what you're trying to do is saying that, oh, this customer looks exactly like the customers that signed up today, but they actually signed up 10 years ago, back when it was another company that we acquired, right? And we're trying to force that to look like the new system. With temporal modeling, you can start looking at systems as long-running processes that happened in, and events that happened in some model, and the new ones happen in a different model. And then we can start migrating some of the V1s to V2, but maybe not even all of them. So maybe we keep parallel versions of the model in production for a very long time. Right? This is advanced stuff, but it's incredibly powerful because we're now not stuck to evolving or migrating something or migrating everything at the same time. Right? Why is that so migrating everything at the same time is it's very risky. You need to prepare it well. You need to test it well. It's scary. Sometimes you even need to shut down the entire system, which is very expensive. Nowadays everything needs to be on 24/7. So and what we do is basically we don't do it. Right? It's too expensive to migrate things. It's too risky. So we keep the existing models and we just sort of keep on piling on hacks and changes and so what happens is that our system, the model in our system, drifts from the model that actually exists in the domain, the conceptual model in the domain, the mental model of people. So they work a certain way. They think, oh yeah, we change this and now we do things this way. In the software, it's still the old way with some layers on top of it to sort of fix it, right? That's how you get legacy code. That's code where the model in the code doesn't match the conceptual model in the domain anymore, right? And it becomes very expensive because, oh yeah, but this, you have to store it that way because of, it used to be like that, and here's another workaround. And the worst example of this is the sort of, maybe you've seen it, the databases where there's extra field 1, extra field 2, extra field 3, and then you need to somehow remember that extra field 3 means, I don't know, the gender of the user unless the user was stored during a full moon, and then it means the number of I don't know. I'm exaggerating, of course, but the point is these systems evolve and they live for a very long time. Some of them are going to live much longer than we do. So far we keep rewriting all our software all the time. That's not going to last. So we need to start thinking in the becoming of the 3Ps, right? Allow that to exist in the system. Here are version 1 customers, and they still work the old way, and some of them and here are version 2 customers, and some of the version 1 customers have some migration path to version 2, and some of them are already at version 3, and we can do sort of soft releases of features, and all of this sort of stuff we're going to have to get much more comfortable with if we're going to build systems that are going to last hundreds of years instead of weeks. I have no idea how long I've been talking, and is maybe some questions, and is this making sense? Is this interesting? Is this?
Yes, I have a question regarding if I get you correctly, like the example with insurance, like you did not migrate insurance. I mean the events from old ones to new ones based on the changes in the the regulation.
Yeah.
You like keep both of them, and like you added events to a stream of events of an insurance that transformed somehow the insurance in the new one?
None of that happened. That system that I'm talking about is that company is 120 years old. The system or the software, they started automating 40 years ago. In fact, one of the people who started the first automation project in that company was in my session, which was very interesting. What we did was not completely redesign the system as an event source system. What we did is we did modeling. We modeled how the business worked. We modeled how people thought about it. We modeled the mental models and the conceptual models. Oh, when a product changes, it has impact on existing long-running processes. Some of them we want that impact, some of them we don't want that impact. We started visualizing all of that. We started trying to understand that. And this was, even though they had been building software where the product changes and then they need to collect another graph from somebody, from the customer to accept the new changes, and then they did migration and they did manual work. So they have been building software that did all that stuff. But it was incredibly painful and expensive and required lots of manual corrections, etc. All of these problems are not fixed in a couple of weeks. But what we did fix was we started modeling it in this way as opposed to structures, and we started seeing what we actually. This was the first time that they actually saw what they meant, what they had in their head. So it's the first time they could actually see the visualization of it and start understanding a different way of looking at it. The process of actually changing the software will take many years still, and it will never be completely fixed. They will always have that legacy. But they understand it now, right? And they can compare how the software works. So the as-is model, they can compare it to the conceptual model, right? So it's not just code, right? Temporal modeling is understanding how it works first. Ideally, of course, that will then translate into temporal model in the code, but it starts from understanding it. Right?
But if it indeed translates into something, into changes in the code, what the changes would be? I mean, if you indeed added new events into the stream of insurance, just to show that somehow it's influenced by changes in regulations or whatever.
Yeah. We did start looking at what kind of changes can we do now, as opposed to, so not like a big design of a 3-year project or something, but small things that we could start doing, and that's the sort of keep the entities, etc., but start bringing more explicit naming into the entities, for example. So it's very simple things, right? So instead of just having a customer entity, start calling it a customer v1, or rename it. Have 2 objects where before there was only 1. So even though it's not a full, so underneath there's still the old database, right? It's still they read from the same table, but instead of both calling them customer and having I don't know, some conditionals that check what type of customer it is, we split that into 2 customers, two types of customers, so that we can move the behavior to each one of those. And then maybe there's the next step could be there's an explicit migration. So we still have, it's still very much a traditional object oriented. Well, a lot of it was not even, doesn't even qualify as object oriented. But now we've separated these concepts because we understand that they are not the same thing. Somebody who signed up in the first version and somebody who signed up in the second version are not the same thing. They're very similar, they're not the same thing. So we make that language explicit, right? We're basically saying that the evolution of the system is also the problem domain. So the problem, you have 2 problem domains now. You have insurance, and you have the fact that there were older versions of how we did insurance, right? That is now explicit in the system. And now we can, now that we have that, we can make the transformations explicit. There can be, well, let's imagine it's a customer v1 object. It has a method called convert to customer v2 that makes the changes, and maybe it needs extra data and whatever, and then writes that and, I don't know, gets rid of the old one or something like that. Or so it's expressing the temporality of the real problem into the things that we see in the system. Right? You do that. You already do that for some things, for very common things. For example, when you make an object that is called a bank transaction or something like that, it is basically an event. It is not. We model it as an entity, and it is an entity in the sense that this bank transaction has another identity than this other bank transaction. Maybe it's the same amount, maybe it's the same bank accounts, maybe it's even the same point in time, but it happened twice, so I have two bank transaction entities. They're both entities and events at this point, because they also represent the point in time where something has changed and the information relevant to that change. Right? So you already do that. You already do some expressing some temporality in your systems, but usually you do it when the business has already understood that that's what it is. Like a bank transaction, they have already understood the concept of a transaction being a point in time where something changes. Not just a thing, but a point in time. What I'm saying is look at everything that way. Start by looking at everything as well, transactions basically, and then model the structures that you need. Any other questions? We should probably... We
have time for one more question.
All right.
Don't be shy, please.
Well, who think, maybe I have a question then. Who thinks this was useful, or will this maybe change how you start? Oh, excellent. Change how you start doing things. Maybe, well, maybe not tomorrow, but maybe after a while. Well, of course you cannot know that, but let me know if this does impact you. I'd love to know about it. If your whole business fails because of it, I also want to know. But there's of course a risk of over-designing and looking at everything. I've seen people who really wanted to do things like event sourcing and DDD and take some problem that doesn't deserve it and completely over-design it. So some restraint can be good. On the other hand, you're never going to learn if you never over-design. Sometimes you need to do a bit too much, then realize that it's over-designed. That's the tricky part. And then the hardest is getting rid of that over-design again and accepting that, well, this is a very nice model and it's my baby and I love it, but I'm going to make it simpler again. And this is really just a CRUD problem or so. Anyway, that's I think that's our time then. So thank you very much for listening.